Hello fellow YouTubers, friends, watchers, engineers, mechanics, car nutters, whoever you might be, welcome to the channel. Thank you for joining me again. Can't remember which part this is. I'm sure it'll show up in the video title. What do I have for you today? Well, some good news, some not so good news, and some kind of iffy in-betweeny news. The iffy in-betweeny news is that the project may take a little longer than I anticipated to finish. The bad news is that the reason behind that is that I'm not going to be in this location to be able to finish the car and work on it as often as I would like to. Which brings me on to the good news, the reason behind me not being in this location. I have, as you all know, been out of work since the beginning of the coronavirus pandemic, and that has put on hold the purchasing of large required equipment for the micra project. That has now changed. I'm pleased to say that I have been offered the position with BAE Systems, so I'm now back into working on aircraft, but that does mean I'm going to be moving back down to England, not permanently, and my family is staying here, but I will be working from England during the week and occasionally at the weekends. So my funds and my the project, as far as buying parts is concerned, will continue to move forwards. However, the work on the car will be restricted to weekends and holidays from in the next couple of weeks anyway. So with that, the videos will be slightly longer, slightly more involved, and what I will try to do is, now I have the funds, I will get a tripod and potentially even a GoPro instead of filming it on my phone, and film some time lapses with me actually doing work on the vehicle over the weekend, and then publish them either on a Monday or a Tuesday once I'm back down at the RAF base. That's the plan. However, things may change, of course, with me starting the new job down there. It is a job I've done before, however, it's for a new company, and I would like to settle in first and build a rapport with the company and learn the ropes first before trying to spread my knowledge and my concentration too thinly across different projects. But it's not stopping. It is carrying on. The videos, like I say, they will get more interesting and longer, but they may take longer to produce. So hopefully you stick around to watch that. The other good news is that I have managed to buy the rest of the parts I need in the drive line, other than the other than the differential and the drive shafts. Drive shaft are going to be slightly difficult because of the length. I have been looking at, obviously I said in the last couple of videos, a Honda S2000 Torsen differential. They're cheap, they're available, they're relatively easy to modify, and they will fit in this location. With that, you get output drives with a bolt-on flange on them, so you can bolt on CV joints instead of having slip joints like on the like down there. So that's a slip joint constant velocity. So you've got constant velocity joint in there with the ball bearings on the end of the drive shaft, and then this piece here goes straight into the differential on the micro engine. Instead of having this here, what you'd have is this section with a flange on it, usually 5 or 6 bolt flange, and then the CV joint has another 6 bolt flange on it, and they bolt together. What that allows me to do when they're in the diff is hopefully find a drive shaft that will fit the wide track suspension that will be able to reach the flange for the output drives on the diff. So if it doesn't, say if it's 3 or 5 or 10 mil out, that can be spaced. So you can put a spacer between the flange of the output drive and the flange of the CV, and alter the length of the drive shaft to get it to sit where it should be, and to seat in the wheel bearings on the hubs. What that allows me to do is to have shafts that are not 100% the exact right length, and that might sound counterproductive, but with that gives me an adjustment on the diff left and right to get the chain aligned correctly. Say for instance I weld up the cradle and put it all in, and for whatever reason it shifts, or there's a misalignment, or my measurements aren't quite as accurate as I thought they were, and it moves slightly and the chain isn't perfectly in line, that's no good. I would rather adjust the length of the shafts by 3 or 5 mil and shift the differential over than have a chain jump off or prematurely wear out. So that's my goal with that one. I have been looking at S2000 drive shafts as well, so that it would all be from the same vehicle, and then on the end of the S2000 drive shaft, I do believe is a normal CV. So as long as that normal CV can be made to fit a wheel bearing in this hub, then it'll just bolt in. If not, I can change the CV on the end of the drive shaft. Hopefully the splines on the drive shaft that go into the CV can be adapted or machined, or I can find a hub, say from an Almira or a Primera, that will bolt onto the drive shaft. If not, we'll go down the opposite route, and we will use the original micra outer CV joints, use a length of micra drive shaft up to a certain point, say in the middle of the drive shaft there, and then use S2000 drive shafts from the differential to the micra ones, and then weld and sleeve them in the middle, or at least measure them, and then see if I can get a drive shaft, main shaft, made at a different manufacturer, and then have them the correct length, with again the ability to adjust them left and right. What else do we have? Well, we've got the 45 tooth sprocket, as you've seen. We've got a Renthal 14 tooth sprocket, which is steel as well. So that's made of steel. This is made of steel. It's all machined steel. And we've got a heavy duty drive chain as well, which will need shortening obviously once I get the diff in place and locate all this in the right location. This has just arrived this morning, having had a complete and total meltdown with the Royal Mail for not knocking on my door when I was in, and basically leaving me 4 days short of having this. It's taken them 4 days to deliver it past the delivery date. However, it's here now. It's brand new. What is it? It's the voltage regulator for the motorcycle engine. Now, on a car engine, or cars, trucks, whatever you might be into, whatever is your pleasure, floats your boat, trips your trigger, whatever you want to call it. The voltage regulator is included in the alternator. And what that does is the alternator produces a voltage that is sinusoidal, so it goes up and down, up, down, up, down, up, down. Hence the term alternator. It's alternating current. It flips from positive, negative, positive, negative, positive, negative. What this does, which is, again, it's usually included in your alternator, is it takes the positive and then negative, and it reverses the negative pulse, so you get positive, positive, positive. What happens then is it goes through a rectifier circuit. A rectifier? Is it a rectifier? No, because, yeah, Yeah, that's DC. Anyway, it goes through a smoothing circuit, a filtering circuit. So instead of being bump, 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 it tries and cuts the peaks off. So say if your alternator is kicking out, it will probably be throwing out from peak to peak, positive to negative, 28 volts or 30 volts. So positive, negative, positive, negative, positive 15, negative 15. What it does, it flips the bottom, the negative wave in between the other ones, so it goes bump, bump, bump instead of up, down, up, down, up, down. So you've then got a positive line of 30 volts, 15 volts, sorry, and then it'll cut the tops off the bumps, so it's a square. So you get a square. That will then feed into your battery. It'll be, obviously there'll be multiple stages of that to smoothen it out, which then goes into your battery and charging circuit, and charges your battery up. You can't charge a battery up on alternating current because a battery is obviously DC. It will only charge one direction, so it'll only charge positive and negative. It doesn't flip-flop AC. If you've seen any, standalone battery chargers or phone chargers or anything like, well, not necessarily a phone charger because that's USB, but these style of chargers here are the same kind of thing. What they do is they take, say if your wall socket is your alternator, this is the voltage regulator. So this changes 230 volts at 50 hertz to 9 volts DC. So that's what this does, and the voltage regulator here does that for the motorcycle engine. So what I'll do, this is a first, I'm going to do some work on camera. So we'll open the bonnet like so. Doobly doobly doo. Stick that up there. And I'll plug it in. So where are the plugs for it? Well, I'll sit this down here on the electronics tray for now. What I will need to do, looking at this as a voltage regulator, I'll probably mount it. Where should I mount it? It needs to be mounted somewhere sturdy. It's quite bloody heavy. It's ugly as hell, that. It's going to need to be probably up there. I'll move the horn and probably mount it there, which means the cables will have to reach across that way, which is lucky because they're just here. So we have the male ends and the female ends. This actually, the voltage regulator looks brand new as well. It was only 12 quid, so I can't complain. So we've got large spade, small spade, and 3 medium spades, and that looks like this connection here. Yep, and then the other one is 2 large and 1 medium spade. 2 large, 1 medium spade. So yes, I thought I'd check before I went any further. So that cable goes around that way. Click. And this one, let's have a look. That's at the top that way, so that can go in that way. Oh, that wasn't quite as satisfying a click as the first one. So yep, this cable will run down here. I will be removing this fuel. In fact, I'll do that now. I'll get some snips. That's a fuel pump relay, which isn't needed at all because I have a standalone fuel system. So goodbye fuel pump. Ugh. Oh god, I can't do that with my left hand. Jesus Christ. Do myself an injury with that. There we go. Don't at me at why my right hand is stronger than my left. We've got, yeah, so the cables will run down here, like so. I'll cable tie those. I might even get some stainless P-clips and screw them into here so that that's stood off like that, and it doesn't interfere with the mains battery connection just there. Again, I might even make a cover for all this. I've got enough aluminium to make a cover, and then make it pretty, paint it, whatever. And then this will either, I could mount it there to be honest, but if I get a 10mm, here we go, hunt for the 10mm. I did tidy this up not long ago, didn't I? It serves me bloody right if I can't find one. There we go. That's, which size is that? Is it 3/8? That's a quarter drive. Where's a 3/8? Never a bloody 3/8 when you need one, is there? There we go. No, that's 1/2 inch. Well, gents, I'll have to settle for manually. I can't do it with the impact driver because I've lost the 3/8 adapter. Yippee. Is it in there? No, it's not in there. Is it up there? No. Beautiful. Did I leave it on the side? No. Feck. Right, okay. Not to worry. I have hands. Well, hand. I will prevail. If I can get the socket on the... There we go. Right, I got the socket on the ratchet. I'll hold you with my left hand. Do the, as AVE says, do the old Rhodesian reach around and use my left hand. Go on, be a 12mm. I dare you. It's not, it's 10. There we go. This is not easy with one hand. Struth. You will come off, you turd. This is being unceremoniously evicted from the bodywork because, as I said, I'll probably go for some Nautilus horns in the future. Now, I have had some information, some advice from the ZX9R Facebook page, a few of the owners on there, and the kit car forums as well, that are saying that the ZX9R, while being a very powerful motorcycle engine, or a very powerful 900cc motorcycle engine anyway, at around 145 to 150 horsepower, the clutch is perfectly fine for use on kit cars up to 500 kilos, or half a ton, or 1,100 pounds, or however you measure it in either Europe, Britain, America, Australia, wherever the hell you are. So this car is not going to weigh 500 kilos. It's probably going to weigh more like 650 or 700 kilos. So with that, they've recommended upgrade the clutch. I'm not going to do that until it's running and driving. If I drive it around and the clutch wears out, I'll get a new clutch. They've also said that the gearbox may not last very long with this kind of weight behind it. I would dispute that because of the number of kit cars and buggies that are used on race event after race event, and the gearboxes are never a problem. It's usually the chain that wears out. Chains are about 20 quid, so that's not a massive problem. If the gearbox goes, you can buy gearbox kits, even race gearbox kits for peanuts. The couple of £100 for a full new set of gears, so I'm not too worried. Like I said, the engine itself, including the gearbox, was only £200, and a new one is only £400. I could go with a ZX9R engine, which would go straight in here for 180 horsepower, and that one they go for about 800 quid to 1,000 quid. So, you know, in the future, once finances are settled and I'm actually getting paid, then, you know, there's always the option of changing, upgrading, Hayabusa. I don't think a Hayabusa engine would fit in here because of the length of it. This is only 900cc. A Hayabusa's 1300cc, and it's not necessarily wider, it's taller. You end up with an engine about that tall, with the throttle bodies on as well, and you're up above the bonnet. You'd have to cut a big hole in the bonnet or drop it down so low you wouldn't be able to drive it to fit a Hayabusa in here. That's why many Hayabusa swaps go in the back, because there's a lot more headroom. You can lift it up a lot more and fit it in. GSX-R 1000s are pretty much the same. They're a long engine, with the position of the gearbox being slightly more under the engine than behind it. ZX9R, same deal. Big engine, even bigger than a Hayabusa, more powerful in fact. But again, not going to fit in this kind of space. Without serious work with either dry sumping the motorcycle engine and dropping it right down, or cutting holes in the bonnet, which is two things I don't want to do. So this is ideal for the minute. It's a 900cc. I could probably get away with, like I said, a ZX10R engine at a later date with the slightly stronger gears and more powerful throttle bodies rather than carburetors. But like I say, if the clutch wears out, I'll put a new clutch in it. If the gearbox wears out, I'll probably just buy a new engine. And then, because I've seen these engines, these gearboxes, and this kind of driveline running turbochargers on top of the 150 horsepower, maybe running 180, 200 horsepower. In drag bikes, and they're putting a lot more load and a lot more stress with higher gearing through the sticky back wheel of a drag bike than I would ever be putting through this in the car. It's not going to do full bore standing starts. It's not going to be spinning the wheels or anything like that. It'll be setting off, and then it'll be, once it's in motion, it'll be going through the gears. And the difference between the gear ratios will mean that the torque load, the initial torque load of jumping off the clutch, won't be as high as, say, if it's geared much higher. So if you're the difference would be if you were flat out in first in your car and you jumped straight to third with your foot flat down, the amount of torque going through the clutch and the driveline is a lot higher than if you go first to second. So that's basically what I'm doing. A normal motorbike would be gear ratios 1, 3, 5, 7, 9, blah, spread out. And the gear ratios in this will be 1, 2, 3, 4, 5, 6. So they're much closer together. So the loading won't be anywhere near. I mean, I think sixth gear in this will be geared slightly higher than fourth in the motorbike. So it's not. It's within its parameters, and I'm going to make the car lighter as well. Yes, it's still quite heavy. However, it will be getting lighter. The plastic windows in the back, there are companies that make fiberglass tailgates and doors. I don't know if I'm going to go with fiberglass doors because these have got the steel reinforcement beam in. However, I do have door bars for the roll cage. So whether that's going to make a difference or not, I don't know. If I do fit fiberglass doors, or at least cut the insides of the doors away and remove the window winder mechanisms, then I will have to run the door bars. You can't run a side impactless door without door bars on a roll cage. It's just not worth it. Even the lightest impact, say if a scooter hit you at this side, it'll bend right in. You could puncture a lung or break a leg or anything. So it's just not worth it. As far as making it much lighter elsewhere, other than cutting brackets out, there's nothing left in this car that could be made any lighter. It's got Kevlar bumper, it's got fiberglass wings, it's got big chunks of metal cut out the back. There's no interior in it, there's no dashboard, the wiring loom's been stripped right back. The exhaust is going to be a lot shorter than it is now. It's going to have a lightweight battery in it. It's only got one seat. It's got no seatbelt inertia reels. It'll have plastic windows. It's got about 60 kilos of engine and gearbox that have been taken out of the front end. So overall, I believe this car's going to be in the high 600s, low 700 kilos range. I want it to be under 700 kilos. If it's not under 700 kilos when I weigh it and when I finish it, the other things to consider doing on this would be, well, the major thing, the heaviest thing on this vehicle at the moment is the wheels and the rear brakes and rear axle. The rear axle in these things is a huge beam of steel, and the drum brakes on the back are about that thick on the outer edges. There's no need for them to be that thick. You can cut them right back to, well, say normal dimensions of a drum brake, and they will still perform perfectly. There's hardly any weight in the back end, so the operating temperature of those brakes, or the operating potential of those brakes, the amount they actually operate, is very, very low anyway. They're really pretty much only used for handbrake. So taking a load of material out of them isn't a problem. It's been done before by, believe it or not, the previous owner of this vehicle on his other micra. So I know it can be done. I know it can be made lighter. And there's also things like the tailgate struts, brackets for the rear seatbelt mounts, rear seat mounts. There's one just there. And all that kind of stuff. Once that comes out, I reckon I can get this car under 700 kilos. Failing that, I'll go on a diet or make it remote control, because I'm 100 kilos anyway. So it's going to be well over 700 kilos with me in it. And a full tank of fuel, obviously. So, where were we? Oh, yes, voltage regulator. So this power cable will run down here, and then I will bolt this somehow, in some way, there, and then build a cover for it. So if I put it that way, yeah, that's better. If I put it that way like that, it pulls all this tight-ish. Put that under there. If I put this underneath there, I can run that like this. Oh, that's perfect. Look at that. So if I run that there, as the voltage regulator, and tidy all these cables up like so, then we have all the motorcycle cables in one location. And the last thing I need to do, well, I say last thing, there's loads of things to do. The last major thing I need to do for the electrics is the fan switches and temperature switch, temperature sensor. The speedo drive, which I believe I might be able to fit back on once I get the chain and everything in. So I can have, yes, the speedo will be inaccurate because the wheels and gearing's different. However, what I can do is put a new set of stickers on the speedo face itself. So go out with a GPS speedo and actually mark down on the face of the clocks the correct speed for the correct position of the needle, and then I've got a speedo, so that should work. And then this one, sorry, you're not even looking at me, this one here, that's from the stator. So that's your alternator plug there, which comes from down there. So once I get a stator and a cover and a big nut for the front, because there should be a nut in there, and there isn't, so I need the nut, the stator, and the cover and gasket to go on there, because this holds oil in here. Then I'm good to go, pretty much. It's just fueling after that. Yeah, once I get fueling, fuel pump, so it'll be ZX9R fuel pump, fitted somehow. Probably use a swirl pot. Like I say, I use the standard micro fuel pump to pump fuel into a swirl pot, and then use the ZX9R pump to pump straight into the carburetors. That way I don't need a regulator for the carburetor side, and I could fit a regulator pre-swirl pot so that the swirl pot doesn't overflow. I can put a cut-off switch, or a fuel level switch, or just a return line straight to the tank. Either way, I've got it sorted. I know what I'm doing on the fuel side of stuff. This bracket does need to be remade. This was a bit of scrap again, just to get the throttle cable positioned. And it isn't particularly well positioned, but it's there and it works for testing purposes and to get it on the road, or not on the road, on the running. So that's it works for now. It's sturdy enough, it's not moving anywhere, and I can make another one or buy one at a later date, get one made. Yeah, vacuum hoses. If anyone has any idea where all these bloody vacuum hoses go, please let me know, and please tell me which ones I can get rid of. This one's a fuel hose, so that's not one of them. But yeah, it was all these vacuum hoses. I have been reliably informed as well. The two hoses coming from the back of the oil filter are not oil coolers, or not an oil cooler. It's an oil warmer, which, boggles my mind. But apparently, it's a water to oil heat exchanger. And it's not oil that goes through these pipes, it's water from the radiator, so that the main radiator for the engine coolant cools down not only the engine coolant, but also the engine oil by the transfer of heat from the oil to the coolant through the little plate behind the filter. So these pipes here are water pipes. One of them apparently runs up this way, which it does, it's there, into this section here, which is a block of some kind, a joining block. So that goes into there, that comes from the back of the engine block, and then that goes down there to the water pump. So that's correct, what he said there. It does go into the water pump. So what I need to do is, this hose here needs to be connected to my radiator with this hose, which is the top hose. And is there a bottom hose? There's got to be a bottom hose somewhere, isn't there? Yeah, down there. So that's the bottom hose down here, and you can see that. There it is, peeking out. That's the bottom hose. That's the top hose. That's the radiator, which is an EG Civic radiator. So what I'll probably do is get a T-piece to go, when I put the radiator in, you'll have the bottom hose going to the bottom of the radiator, obviously. And the top hose, I will bring that top hose round here. Yeah, I'll bring it round the front, just in front of the grill, or behind the grill. Once this, the old slam panel is on here, which does fit, by the way, with a little cutout here. I'll put the old slam panel in here and the radiator, and then obviously the top hose can come round this way, back up, and back into the, so do like a 90 left and an 180 right into the top of the radiator. But along this route here, where that hose is, I'll put a T-piece just there. So it'll be flow going across that way, which will draw water out of the bottom one here. So that'll get that sorted once I measure some hoses and get some silicon sorted and that kind of stuff. And then it's just a case of diff again. I keep saying this every video. It's differential is the biggest thing at the minute. Diff. I need the differential to be able to mount the chain, the sprockets, the drive shafts, do the rest of the cradle at the back, brace the engine even more, so fix this one over here, which isn't touching the chassis at the moment. Probably going to triangulate the middle of this plate to here, because at the moment the entire engine is hanging on the front half of this plate, which, yeah, it's strong enough, but it only needs a little tweak and it'll start wiggling around. So that from this mount here to the bottom of this plate down here will be my next job. be there to there. So you've got a triangulation. And then, yeah, continue working on it. So that's where I am for now. Got the chains and sprockets up here. So that's the gearing sorted. You saw me put the voltage regulator in, so that's that sorted. Just needs a, like I said, a bracket and a cover. I've got some in my box of spare bits of metal. This is, as you can see that. Well, it doesn't say bugger all on there, does it? It says AMS 4037, which is 2024 T4, and it's less than a mil. I think it's can't even focus on it there. I think it's 0.2 or 0.3 of a millimeter aircraft aluminium, which means it's very strong but very brittle. You can only bend it once, and you can't bend it very, very tight radius. It's very, very easy to cut, and it's very lightweight. Obviously, it's actually Chinook helicopter aircraft skin. There's a spare sheet when I left the RF Odium on Chinook helicopters 3-4 years ago now. There was a sheet in scrap that was going to go straight in the bin that had a bit of a slice in it, a bit of a wibble in it, and it was liberated from its coffin, from its demise. And I also have a couple of these, which are Chinook helicopter transmission blanks. So the transmission for the Chinook helicopter, forward and aft, it says on there, transmission gearbox blanking plate. So that's what this is. Again, these were old stock, old scrap. You can see all the sealant and everything around it. These were in the scrap pile, ready to go in the bin. I got maybe 6 or 7 of these. There's another one there. There's this one here. And I've made part of the dashboard with one of them as well. And that plate down there is made with one of them. So this I can actually use, cut out some pieces, make it the right shape, and then use that as a cover for the electronics. Come in handy, these things, little bits of aluminium, little bits of scrap. This is a bit thicker than the aircraft skin, and it's a lot more flexible. You can bend this a little bit more than you can the 2024. I don't know what grade this is. It's not. I don't think it's aircraft in quotation marks. Aircraft aluminium. I think it's actually just aluminium plate. Whereas that stuff, the blue stuff here with the covering on it, is 100% aircraft grade aluminium. It's from an aircraft, so it has to be aircraft grade, doesn't it? So that's that bit. That's me. That's my plan. That's where I'm going. And like I said, progress should go quicker initially, and then slow down as I start working down in England. However, the projects that will happen will be much bigger single chunks. So instead of having little updates every now and then, the updates will be much more substantial. Thank you very much for joining me. Don't forget to like and subscribe. Become a patron if you want. Being a patron is very, very easy. You click on the link in the description below. You click on which package you would like to join. I don't have anything to offer extra in the packages just yet. Like I say, I'm just starting out at this. However, if you do become a patron for $2 a month or $2 a video or whatever you want to do, then that will help the channel and it'll help me to progress the build. Everything that you would donate on Patreon or on YouTube or on Facebook or however you want to do it, or if you do want to do it, that will go straight towards the build. It doesn't go towards me at all. And thank you very much. Please like and subscribe, and I shall see you in the next video. Thank you very much.